Assalamualaikum dan salam sejahtera. I am Puan Azlina binti Hairi from Polytechnic Prodison. Today I would like to present an innovative project with my student entitled Poultry Feeding and Lighting System using ESP8266 MCU. Table of content. First, introduction. Second, methodology. Third, result and analysis. Fourth, conclusion and suggestion. Number 1, introduction. In 2020, Malaysians consume 47.4 kg of chicken meat and 20.7 kg of chicken and duck egg per person, compared to other meat such as beef and goat meat. Almost all the grain needed are imported from the United States. 80% of its grain come from Brazil and Argentina, while 96% of soybean come from Argentina. This caused grain prices to rise, pushing up costs for chicken farmers who were already suffering from a falling ringgit. Chicken farming has two categories, which are traditional chicken farming and also commercial. Traditional chicken farming use the free-range environment, while commercial chicken farming use a closed housing system and implement modern technologies. For objective, to produce this project, 3 objectives have been identified. First, to develop a poultry feeding system using ESP8266 for farmers to control food feeder. Second, to build a poultry lighting system program using an LDR sensor in the coop to control the lighting. And the third one, to enhance the poultry feeding system by using the Blink application. For the scope, the automatic food feeder is designed using the Blink application. Farmers only need to install Blink on their mobile phone. 3 on button represent the time to feed the chick, namely pagi, tengah hari and petang. After the button is pressed, the servo motor will be activated and then the food for the chicken will drop into the food bowl. Other than that, we use dry food or broiler crumble using Blink apps, ESP8266 non-MCU, servo motor 5 volt, age of chicken 2 to 3 weeks, material cylinder food storage, plastic, bell drinker automatic for water storage, area of scope for prototype use only, 2 feed times 2 feet, 1 LDR sensor module, and 2 unit of bulb 20 watt. Number 2, methodology. How it works. Farmers need to install the Blink apps on their phone and register. After the first step is complete, the farmer need to enable notification for the Blink app on the phone. Then prepare the dry food evenly by entering the time on this app. In addition, farmer will be feeding their poultry 3 times a day, in the morning, afternoon, and evening. The farmer will set the drop feed to the EOS feeder within 10 seconds. As for the lighting system, the LDR sensor will detect if it is dark, the bulb will turn on automatically. Otherwise, if the LDR detects the light, the bulb will not turn on. The light from the bulb helps this chicken stay warm and get light at night. And this is block diagram of the project. We have 2 input here, which is power bank and LDR sensor, and the processor is ESP8266 non-MCU, and for the output we have servo motor and also bulb. Number 3, result and analysis. For the result, this project has been successfully developed where the chicken feeding and lighting system that can connect mobile phone so that user can monitor anywhere and anytime as long as the mobile phone remain connected to the internet. It will benefit and ease the burden of farmers by managing their time wisely and avoiding the wastage of electricity. When the farmer gives instruction to this blink app, it will drop the food fall into the bowl within 10 seconds. For lighting system, it used to give light to the chicken at night, while during the day it is used through natural light. For analysis, this is chart of food required by chicken versus time. By referring to the schedule obtained from the Jabatan Perkhidmatan Veterina related to laying hens, with the area of the chicken coop measuring to feed time to feed and the number of 2 to 3 weeks old chicks of 10, the amount of food required by one chick is 8 grams per meal. This chick need to be fed 3 times a day. Therefore, the average amount of food taken by a chick in a day is 24 grams. The analysis that have been made consider the amount of time that need to be set on the servo motor to work so that the dry food come out in the right amount and avoid food waste. Found 10 seconds is the right time to set because the amount of food that will come out is as much as 80 grams. The setting for the servo motor can be changed on according if the size of chicken is growing and the amount of their food need to be increased. Number 4. Conclusion and suggestion. In conclusion, using ESP8266 non-MCU is an innovative project to transform a traditional coop into a smart coop. The system could work on the application of smartphone, helping the owner to monitor chicken feeding and lighting system. 3 objectives need to be achieved as a solution to the problem faced by poultry farmer. All objectives in this project have been successfully achieved. First, the ESP8266 has been successfully programmed according to the user need. It will process the instruction to activate the servo motor and let the servo motor rotate for 10 seconds to allow the crumble to drop. Second, the LDR sensor also works well where it can detect light. When it is dark, the bulb will light up, and when it is bright, the bulb will be extinguished. Third, blink app have also been successfully built and used where user only need to press the button on the smartphone display to feed the chicken according to the time that has been set. For the suggestion, as a backup for improvement to this innovative project, the temperature sensor can be programmed so that the temperature inside the coop can be monitored by the farmer. If the temperature increases, the fan will be on, and if the temperature is low, the fan will be off. This improvement also helps to avoid chicks from being infected with wine-borne disease. This is the prototype of the project where we have 2 bulbs here and also LDR sensor, and the right side we have food feeder, and this one is the blink application on the user phone.
In this video, we show how the LDR sensor works. When we close the LDR sensor, the bulb will light up. When we open the LDR, the bulb will turn off. In this video, we show the blink application connect to the servo motor.
That's all from me. Thank you.